Greetings, folks. Notice the shirt. I'm being exotic tonight. This video is designed to give you a quick look at an electrical circuit. I'm going to show you the schematic. I'm going to talk a little bit about the elements that go into making up the schematic. We're going to talk a lot about this stuff in class, so this is just going to be kind of a preamble. It'll be short. So here we have a very simple electrical circuit. It's powered with a DC power source. It's comprised of a high voltage terminal and a low voltage terminal. This is the symbol that's used in a circuit for a DC power source. The voltage difference across the terminals sets up an electric field that, when the switch is closed, motivates charge to move through the circuit. Measuring the voltage difference between 2 points in a circuit is done with what's called a voltmeter. You literally put the leads of the voltmeter across the points or the element that you want to measure the voltage across. They aren't just used across power sources. There will be a voltage change between this side of the resistor and this side. If we wanted to know what the voltage drop was across the resistor, we would put a voltmeter across it. Current is a measure of the number of charge carriers that actually pass by a point per unit time. The meter that measured this current flow is what's called an ammeter. You actually put them directly into the circuit like so the current actually flows right straight through it. This is the symbol for an ammeter. We have a switch, and lastly we have an element called a resistor. This is the symbol for a resistor. Resistors are circuit elements that dissipate energy, and they also limit the amount of current that can flow in the circuit. So if you have a really large resistance to current flow, you won't get very much current. If it's a small resistance, on the other hand, you'll get large current. So we throw the switch. The power supply is now setting up an electric field that goes all the way through like so. All the charge carriers start to move immediately. A tiny trickle of current flows through the voltmeter. It registers the voltage across the power supply, which I'm assuming is 10 volts in this case. You have the same number of charge carriers passing by here per unit time as here, as here, as here, as here, as here, as here. The ammeter registers how much that current is. I'm assuming it's 2 amps just for the sake of argument. So let's say I were to double the resistance. The voltage across the power supply would stay the same. The current would halve, so the ammeter would read 1 amp. So if you were given this problem as a homework problem or a test problem, what would you be given? Well, you'd probably be given what the terminal voltage would be. It would be 20 volts or whatever. You'd probably be given the size of the resistor. It would maybe be 100 ohms. In all probability, you'd be asked to figure out what the current would be flowing through the circuit. Current goes from high voltage to low for reasons that I'll explain later. The symbol for current is I. This is the way it's usually shown on a schematic. And the last thing I'll point out is what's called Ohm's law. And basically what it says is that the voltage across a resistor is proportional to the current through the resistor, with the proportionality constant being the resistance of the resistor. And so here it is out in mathematical form, voltage proportional to current. If you want to make it into an equality, you have to multiply by the proportionality constant, which is the resistance. You double the voltage, it doubles the current. Anyway, we'll talk about all of this in more depth in class. That's it for now.